Sometimes you may find it useful to rewrite expressions with exponents. For example, let's say that we're working with the number 9. Well, remember that the number 9 can be rewritten as 3 to the second power, right? Because 3 to the second power is 3 times 3, which is 9. This may be useful when we're working with things like logarithms. Another example of this, let's go ahead and work with 16. Well, here we can rewrite 16 as 4 to the second power, right? Because 4 times 4 is 16. But we can take this even a step further. Remember that 4 really is the same as 2 to the second power. And so when we have 4 squared, that really means we have 2 to the second power times 2 to the second power. And using exponent rules, we add these exponents, and we get 2 to the fourth power, which is the same as 16. Let's try one more of those with a slightly larger number, 81. Well, I know that 81 is really the same as 9 times 9. And as stated before, we can rewrite 9 as 3 squared. So if we have 3 squared twice because of 9 times 9, we really have 3 to the fourth power. It's also helpful to remember that radicals can be rewritten using exponents. Again, this is very helpful when we work with things like logarithms. Here I have the square root of x. This is actually the same as writing x to the 1/2 power. Thus, a square root is always the same as an exponent of 1/2. The same can be done with numbers. So if we have the square root of 5, we can rewrite this as 5 to the 1/2 power. It's a little bit different if we have an index or a small number here inside of our radical symbol. That simply refers to a change in our denominator of our fractional exponent. And so when we rewrite the exponent on the cube root of x, we actually get x to the 1/3 power. Again, that works with numbers. So if we take the cube root of a number like 100, we can rewrite this as 100 to the 1/3 power. Again, this might be useful when working with logarithms. For pre-calculus, I highly recommend that you commit the following roots to memory. So we have our most common perfect square, or square roots, and our most common cube roots. We can use these when we're working on things like logarithms and exponents to remember things like, well, 1 squared equals 1, right? 3 squared equals 9, right? 11 squared equals 121. And with our cube roots, things like 4 to the 3rd power equal 64. And so if we can work interchangeably, particularly by remembering these cube and square roots, we can be a lot more efficient and not get held up on the little things for more complicated problems like those involving logarithms.